Okay, so let's continue with the collision system, and so far we've managed to push the points along the normals, along the gradient, but it's not enough to properly place them at the iso surface. And if we go back, if you guys remember when I connected the colors here, if we look at the information, it's negative. And then in some areas it's positive, and that's where the points are outside the iso surface. Now here the amount is not the same. You can see it's going between -6 and -1, and that information is actually how far the point is inside the iso surface, how deep it is inside the volume. And that's the information, that's the bits we need to properly push, to know how much we need to push the points along this gradient information. And what I'm going to do now is I'm going to take this output and I'm going to add it to the normals. Okay, sorry, I'm going to multiply it with the normals. So I'm going to first multiply the normals by the SDF, and then I'm going to add this amount, not the normalized, but this amount. You can see here it's doing something, but it's not right. We're seeing the points more, they're getting inside the volume, and that's because we need to invert this information. We need to invert the either this or this. I'm going to negate the normal, so I'm going to negate this using a negate node, and there we go. So now all the points are at the iso surface, and if we go to any frame, it's gonna work. Okay, and the good thing is we're not changing anything that is outside, only the points that are inside. So this is everything, and then this is the result, and we're going to use the system inside DOPS to push the particle out. Okay, now the other thing that we want to do is we don't want to just push them to the iso surface. At least this is my approach. This is what I prefer to do. I like to sample the velocity after they have been moved, and use some of that velocity to push them. So if Kong is moving this way and has specific velocity, I don't want to just push the points out. I want to give them, or let them inherit some of that velocity of where they are located at that point. And what I'm going to do is I'm going to use a volume sample, volume sample vector, because the velocity field is a vector field, and I'm going to say it's coming from the second input, and the name is velocity. So val, and let's connect. The sample position is this new position. Okay, it's not the original position, it's this one here. So I'm going to use that, and let's plug this into the velocity, and let's take a look at the red points only and view the velocity, and there we go. Now all the points are inheriting. If we look here, see everything has the correct normals from the surface. We're sampling that into we're converting that into volume field, and then we're also inheriting that. So this information helps quite a bit with the particle interaction. Okay, to just transfers a bit of information, a bit of velocity onto the points, even if they're not, even if it's not 100% accurate. And that's pretty much it. We need to implement this in DOPS and with particles, but the same approach is we're going to do the same approach, so we'll continue that in the next video. Thank you guys for watching, and see you in a bit.